Okay, in section 8.2 in Algebra 2, we're going to graph and write equations of parabolas. The assignment is 8.2, 3 to 33 odds. Here are the equations that they give you in the textbook. That would be if the vertex is at 0, 0. The better formulas are here underneath. That's where the vertex is HK. If it is 0, 0, like in your assignment, the vertex HK will always be at 0, 0. If it's like one of these on the left where you have a y equals x squared, it'll open either up, or maybe if you had a negative x squared, it would open down. These ones on the right over here where it's x equals y squared, that's going to be a parabola that opens to the right, whereas x equals a negative y squared is a parabola opening to the left. So in general, we have this parabola, y equals x squared. This is a parabola that's going to be opening upward if p is positive. Now there's a focal point in here, somewhere at point F. And this distance is p, so the distance between the focus and the vertex is p. The coordinates of your vertex are h, k. I believe for our purposes they'll be at the origin. Now if you go p units out to find the focus, you also go p units inside, or onto the outside that is, to find the imaginary line called the directrix. The directrix. So you're going to be required to find the focus, the coordinates of the focus, the vertex, which is HK, and the directrix. Now the formulas on the right over here might open to the right. The focus would always be on the inside, and whatever that length is, you'd go the same unit to the outside to make the directrix. Now we're going to look at some of these. We're doing 3 to 33 odds. So number 3 says y squared equals 16x. The formula is y squared equals 4px. As I told you, all of ours are going to be centered at the origin, or have a vertex at the origin. So it's at 0, 0. Just marking off some points. Now, this is an x. Maybe you can look at this right here and see that that's an x equals y squared, which means it opens to the right. So this is going to open to the right, so it's going to be at the vertex at the origin, and it's going to open to the right. If you look what 4p has to equal, in this case it's 16, which makes p 4. I always look at the absolute value of p because that gives me the distance. So I go 4 to the inside. That makes my focal point 4, 0. The vertex is 0, 0. And if I go 4 to the outside, you'd have out here your directrix, which is an imaginary line. That's why it's dotted. If it's a vertical line, I believe it's going to be x equals, and in this case, x equals negative 4, right? So let's try another one. Okay, so again, the goal is to rewrite them into standard form. Number 5 is almost in standard form. Well, actually it is already. You have x squared equals 4p times y. So this is of the form of y equals x squared, which means it opens upward. So when I graph this, I'm going to have my vertex at the origin at 0, 0. Let me mark off a few in each direction. Anyway, we have a parabola, vertex is at 0, 0. And we have it opening upward. Now what is p? If 4p equals 20, p would equal 5. So I'd go 5 to the inside to get my focus. and I'd go 5 to the outside to get the directrix. Directrix is a dotted line, and it's equidistant from the vertex. So this is called the directrix. If it's a horizontal line, it's y equals. In this case, I went down 5. So I believe the directrix is at y equals -5. Number 7, you also have in standard form y squared equals 4px. But if you solve this for x, you'd have x equaling a negative y squared. X equals y squared opens to the right, but x equals negative y squared is going to make this thing open to the left. So I make my vertex. I'll mark off a couple in each direction. I make my vertex at 0, 0. I know that this curve opens to the left. And now what does 4p equal here? -10, which means p equals -10 or -5/2. So -5/2 is -2.5. So I have to go -5/2 to the inside. That makes my coordinates -5/2, 0 for the focus. And if I go 2.5 or 5/2 to the outside, I get my directrix on the outside here. If it's a vertical line, it's x equals, in this case, it's x equals 5/2. So again, I think the key is knowing that if it's y equals x squared, it opens up. Y equals -x squared opens down. X equals y squared will open to the right. And if you have an x equals a negative y squared, like in this case, it would open to the left. That's kind of essential knowledge when you're graphing these or to write equations. Number 5, I think I have to do something to put it in standard form, like divide by 5. Now I have x squared equals -3y. My standard form is x squared equals 4py. Since this is, if you were to solve this for y, I think you'd get a -x squared, which means that this opens downward. So when I graph this, I'm going to mark a few off in each direction. I'll probably make this one a little bigger, just seeing what I'm seeing. Now, if this is opening downward, the vertex is at 0, 0. So we have the vertex at 0, 0. 4p has to equal, in this case, -3. P then would be -3/4, and the absolute value to make it a distance would be 3/4. So on the inside here, you have a focus, and that's at 0, -3/4. And if you went 3/4 to the outside, you'd have a directrix at y equals 3/4. So I have my vertex labeled, I have my focus labeled, and I have my directrix labeled. Now when you get to this next group of problems, they're going to give you information and ask you to write the equation. To do these, I always recommend you graph them. So let's take a look at a graph real fast. 0, 0 is the origin. So I have 0, 0 at the origin, and that's the vertex. The focus is at -5, 0. So 3, 4, 5. My focus is at -5, 0. It'll always open around the focus. So if it opens right or left, it's an x equals y squared type. So my formula is going to be y squared equals 4p times x. So I have y squared equals 4 times p times x. P is the focal length. So this length here is p. P is 5, but because it's opening to the left, we use a negative 5. Whenever it opens to the left or down, the P is going to be negative. P is a length, however, it's negative on the formula. So my final answer is going to be y squared equals negative 20x. Again, the goal is to write the equation. To do that, I recommend you graph it whenever you're given information, such as 27 or 29. 29 gives me these. So I'm going to graph them. So I go to 0, negative 4, that's my focus. My vertex is up here at 0, 0. Has to open around the focus, so that's a y equals x squared, or in this case it's a y equals negative x squared that makes it open downward. So that means I think I need this formula. So I have x squared equals 4 times p times y. P is the focal length. That's the distance from the vertex to the focus, which appears to make P 4 in this case. So I'm going to make P a 4, but I'm going to have to make it negative because it's opening downward. So what that does is it makes my final answer x squared equals negative 16y. And that should be your answer for 29.